All right, in this lesson, we are going to look at graphing polynomial functions. So for the start of this unit, we've looked at kind of some of the properties of these functions, and now we're going to take those properties and put it together to get the actual graph. So we looked at minimums and maximums. So we have what's called an absolute minimum or maximum. Sometimes we call it a global minimum or maximum. And that's just something that's either smaller or bigger than everything else in the function. So maybe the bottom of a parabola. That's the smallest point the parabola ever reaches. But we also have things called local, or sometimes called relative minimums or maximums. And these are smaller or bigger within just a small area. So if we're looking at the graph on the right, there's that little hill, you might think of it as. That's a local maximum. Because it reaches the highest point there, it goes back down, but you can see way to the right, it gets higher than that actual local maximum. So it's not the highest point of the entire function, but just in that area. Same with the local minimum. It's just the lowest point in that area, so we have one there to the right, but it's not necessarily the lowest point of the entire function. It could be though, so in the parabola up above, that is an absolute, and you could say and local minimum. Okay, and those minimums and maximums, they can also be called turning points because the graph turns direction. It's going upwards and then goes downwards, so hence the term turning point. Okay, so if we're going to draw a polynomial, what are we going to use to draw it? Well, we're going to use the end behavior. So that's where we're looking at what happens as you go all the way to the right or all the way to the left. And we also describe that in terms of quadrant behavior. So from quadrant 2 to quadrant 1, that kind of thing. We're going to use the x-intercepts, so the zeros, and the orders of each. And then lastly, the y-intercept is some extra information that we can use to make the graph just a little more accurate. So let's do that for this graph. Okay, it's in factored form. So let's get the degree. The degree is equal to 3 plus 2, which is equal to 5, since we have factor with exponent 3 and factor with exponent 2. We have the lead coefficient, the sign in front essentially, is negative. So then we need to think back to our quadrant behavior, or the end behavior. What happens if you have a negative lead coefficient with a odd degree? This is where, in order to remember these things, I just think in terms of either quadratics or cubics. So a cubic normally goes up from the bottom left to the right, but we have the lead coefficient being negative, so ours is going to now go down and to the right. And there's going to be other things happening, so it's not like a cubic, just a regular cubic anymore, but that will at least tell us the end behavior. So we're going to say from quadrant 2 to quadrant 4. Okay, so that's one thing. The next thing we need are the x-intercepts. So for the x-intercepts, well, it's in factored form. They're right there for us. We have x equal to -3 and x equal to 1. Okay, not only do we want the intercepts, we want their orders. So by orders, we can also say multiplicity. We're looking at the associated exponent. So this -3, the x plus 3 has an exponent 3, so it is order 3. X minus 1 has an exponent 2, so it is order 2. So we have those two orders there. And lastly, we want the y-intercept. And this is just a calculation you'd make. So just plug in 0. See what happens. So -0 plus 3 cubed, it's just 3 cubed. -1 squared. I'll put the 0 there, but it's just The 0 is going to disappear. And 3 cubed is 27. And it's going to be negative 27 once you apply the negative. All right. And so there we have it. That is the information we want to use to graph this polynomial. So let's graph the polynomial. So how I like to start is just plot the intercepts and try to keep things to scale as best as possible. So in this case, you're going to see like, okay, the y-intercept is at negative 27. So it's not going to be the same scale vertically as it is horizontally. And that's okay. But try your best if possible. But definitely like horizontally, like make sure the scale is consistent in that direction with all the x-intercepts if possible. Okay, so we've got a few points there from the intercepts, and our behavior is quadrant 2 to quadrant 4. So essentially what I'm going to do is I'm going to start the graph in quadrant 2, so I kind of started there, and then just basically go through your points, and as you're going through your points, follow the behavior. So what you're going to see here is I'm going towards my x-intercept of negative 3. And actually with all of these points, I want to label them just so that we know what they are. So that's good practice. Make sure to label your points. And the last one there was positive 1. And with those points, what I'm going to do is as I approach them, I'm going to approach according to the order. So the order says this first one is order 3. So it's like a cubic there, which has that kind of curved shape to it. Next, I'm going to go down, and eventually I'm going to have to go back up to the next x-intercept. We don't know exactly how far down to go. That's not something we have found out. I'm just going to go down somewhat to here, and then back through negative 27, so making sure I go through the y-intercept, and then I go to 1. As I go to 1, keep in mind the order. So the order is 2, which means it's like a parabola, which means it's going to go up and go in a U shape, so it's going to hit 1 and go back down. There's no more points that we have, no more x-intercepts. We've already passed the y-intercept. So now we can just continue our graph in that direction, just downwards like that. I'll just add arrows at the ends, and you can see that when we went down, that's following the end behavior too. So that end behavior should follow if you properly follow the order of each of your intercepts. And in this case, I'll just label, you don't have to label the orders each time, but just so that for this first graph, we're reiterating that the order tells us the shape around that intercept. And there's a look at how you can graph a polynomial. So yeah, really we're using 3 main pieces of information: the end behavior, the intercepts and their orders, and the y-intercept. And that can give you a decent graph. So let's do this again. And I encourage you, try this one out on your own. So pause the video and then watch after you've paused the video and tried it out yourself. Okay, so in this case, let's figure out the degree. So the degree, again, just add up the exponents because we're in factored form. That's always the key thing. If they're not in factored form, if you're in standard form, well, then it's just the largest exponent. But we have 2, 1, and 3, which gives us 6. And we have a lead coefficient. I'm just going to do LC for short, which is positive. So the end behavior, so we have degree 6, so we're thinking parabola-like for the end behavior. And it's positive, so just like a U-shaped parabola going upwards, which would mean quadrant 2 to quadrant 1. Okay, so there's our end behavior. So next, let's get on to our intercepts. So we have our x-intercept, which is, well, we have 3 of them. I always like to go in order from smallest to greatest. So negative 7, 2, and 5. And then I'll put the orders of each as well too. So negative 7 has exponent 1, so it's just order 1. So that means there's no special behavior. You're just going through the x-intercept. X equal 2 has exponent 3, so it's order 3. And x equal to 5 has order 2. And lastly, let's do the y-intercept. So again, just substitute in 0. That just means basically those x's will drop away and you get -5 squared times 7 times -2 cubed. And just plug that into your calculator. So -5 squared, just be careful about using brackets to not accidentally mess up how your calculator is interpreting the negative sign with those exponents. Okay, and hopefully you get something like -1400. Okay, so I will plot those intercepts. So -7, I'll put that at kind of the far end. 2 is going to be closer in. 5 is not going to quite go all the way because 7 was all the way out. So something like that. Again, just trying to keep scale. Label those as well. So I'll do -7. We'll do 2, and we'll do 5. And then -1400. So yeah, that definitely can't keep -1400 quite to scale with the rest of it. But there we go. Okay, I'll do the graph in red this time just because. So let's begin in quadrant 2. So we're starting, whenever we're drawing graphs, I always like to go from left to right. So starting in the top left and going towards that first intercept. And we're going with order 1, so I'm just going to draw it going smoothly through there. So no fancy behavior, it's just in a sense going straight through. Just going down, down, down to some minimum. I don't know where that minimum is. That's what calculus will actually tell you. But this is not a calculus course. But if you were to take calculus, you would be able to find that out, and you will do that in the course. But for now, we are continuing through the y-intercept and towards the next intercept, x-intercept. So the next one has order 3. So it looks like a cubic at that order 3 intercept. Okay, so it kind of flattens out there. And then we go back to the next intercept, but we're going to go now with order 2, which means it kind of bounces. It's a turning point, a parabola there. And there's no more intercepts, so we just keep going on upwards now. And that then matches our graph ending in quadrant 1. So there we have it. We have those 3 x-intercepts and the y-intercept. So this is what order 1 looks like. Order 3. Again, you don't actually have to label the orders. Just doing it for these initial ones. And order 2 there. Okay. So some important key facts. We briefly talked about them in an earlier lesson. But again, just to reiterate and really get us more confident with these polynomials. So if you have an odd degree polynomial, your polynomial does not have a maximum or minimum. If you take a look at the first graph we graphed, there is no absolute max or min because you're starting in the one quadrant going to the opposite quadrant. So you'll never actually have a point that is the lowest or the highest. You can always get lower or higher. You could still have local maximums and minimums, and at most you will have one less than the degree, but you could have none. And x-intercepts, you could have at most n, but you have to have at least one because if you're thinking about the n behavior, you're going between, in a sense, opposite quadrants, so you're crossing the x-axis at least once. And for an even degree polynomial, you could have a maximum or a minimum, an absolute one. It just depends on if your lead coefficient is negative or positive. And that will tell you whether you have a maximum or a minimum. And for the number of local maximums and the x-intercepts, it is, in this case, kind of similar to what we had with the odd degree polynomials. You can have one less the number of local maximums and minimums than the degree, but you could have up to the same number of x-intercepts. Okay. So now that you've had a chance to draw a couple of polynomials, let's just take a look at a graph of a polynomial and just figure out the order or figure out the degree of this graph using the orders of the x-intercepts. because we looked at this kind of question a couple lessons ago. I was using like minimums and maximums, but now with a little more familiarity, we're going to come back to this. Okay. So let's go through the different x-intercepts. So we have an x-intercept at -2, an x-intercept at 0, and an x-intercept at 1. And we want to figure out, well, what is the order of each of those x-intercepts? We'll take a look at the shape. This one is cubic looking, so that must be order 3. X equal to 0 just looks like it's going straight through, so that would just be order 1. And the last one is hitting the minimum and going back. It's a turning point, so it's like a parabola. It's order 2. So what we can do to figure out the degree of the polynomial, potentially, it's not necessarily exactly, because sometimes there might be other things going on in the graph that aren't present at the x-intercepts. But the degree could be, well, degree equals, I'll just say, add up the orders. It's maybe not the most mathematically nice way of writing that, but it's essentially getting the idea across. So we have 3, 1, and 2, which means at minimum we need degree 6. So at minimum, it's degree 6. Okay. And that's a look at that kind of question. So just using the graph and now identifying the orders to figure out the degree. And in future, we're going to look at how can we get the full equation of the polynomial associated with that graph. All right, and that's a look at graphing polynomial functions.